Hey guys, it's often said that good features are what make or break models' performance. As we know, machines do not understand characters, that is categorical data. They do not understand characters, right? Then how do we work with categorical data? Which should make sense to us and also to a machine so that it understands that characters and help us create the predictive model. We are on part 4, feature engineering in machine learning for categorical data. As I've said, machines do not understand characters, that is categorical data. Then how do I convert that categorical data so machines can also understand and improve models' performance? This is called categorical encoding. So the process of converting categorical data into integer format. Machines understand numbers, they do not understand characters. And converting that categorical data to numbers is what categorical encoding stands for. We have started a new series, a playlist of videos to understand everything about feature engineering. We have already seen data cleaning and imputation techniques in the last video. Now we're going to talk about feature extraction, specifically what is categorical encoding. So if you are new here, I'm a mentor in the field of AI and machine learning. Started my journey long back 12 years before as a mentor, and during this time I got exposed to multiple technologies from Java to DevOps to Python to data science and now also AI. I have been helping corporates understand and implement applications, especially in Python, data science and obviously AI. In this video, we will deep dive and understand how to perform categorical encoding, and there are different types, one-hot encoding and ordinal encoding, and to know and understand how encoding impact on machine learning models. And most importantly, we are going to see the demo example, the hands-on on the same how to perform categorical encoding. You watch this video till the end and let's get started. Hey guys, welcome to AI with AI. This side Asif Imnad. First, let's understand different categorical encoding techniques and what their types are and what each type means here. So as you see in the diagram, we have mainly 3 types in categorical encoding. As you see, first one is the one-hot encoding. This is also called nominal encoding. Then the second type is ordinal or label encoding. And the third type that we have is count or frequency encoding. What does this each type means? When I say one-hot encoding, what it means? I'll just put the definition for now, and in the next slide you will understand what it actually means. So one-hot encoding is nothing but converting characters to a Boolean variables. Converting character to 0 or 1, where idea is just to indicate if category is present for each observation or no, right? Character, convert it to 0 or 1s, binaries, and check if present or not. That is one-hot encoding, or also called nominal encoding. Then the second type, ordinal or label encoding, stands for where you put numbers but not only binaries, you put sequences 0 to n, that is 0, 1, 2, 3, 4 till n, where n is nothing but the distinct categories of the variables, and these numbers are assigned randomly. There is no sequencing as such, but we provide a number, a count, not only binaries 0 and 1s, right? Unlike one-hot encoding. And count and frequency encoding, where you put some logic as well, where each categories are replaced by the count or the percentage of observations that show that category in the dataset. Basically, if certain observations come multiple times, then we need a count, or we need to know the percentage full dataset, then we can use frequency, right? So these are the 3 different basic types that we have in categorical encoding. Okay, before we proceed and discuss in detail, if you are new here, don't forget to hit that subscribe button and the bell icon so that you won't miss our latest videos on AI. We see you are watching our videos, but 90% are not yet subscribed. We put a lot of efforts creating these videos for you free. Keep us motivated by liking and subscribing, so YouTube algorithm will also help us reach more audience. So did you subscribe and like? Thank you. Okay, we have only seen one part in the demo, which is one-hot encoding or nominal encoding, and also the improved version of one-hot encoding, which is K-1 or one-drop feature encoding, right? So now let's talk about ordinal encoding, label encoding, and also the count encoding. Let's see the demo for these 2 types. Okay, what is ordinal encoding? Let's quickly recap. Ordinal encoding consists in replacing the categories by integers 1 to n or 0 to n. It's up to you. You have to decide, right? It's not only 0 and 1. In case of one-hot encoding, we wanted only 0 or 1. Available, not available. But here, I want to do the numbering from 1, 2, 3 to till n, right? So either you do it as a label or you do it as a sequence. This is what we need to decide. Here we're gonna use housing price dataset. Let's do the import pandas and model selection, train, test, split for splitting our data into test and train, read CSV, house price prediction, and these are the columns I'm gonna use. I don't want to consider all the columns. Look at this, and it also makes sense why I'm considering these columns, because these are the columns which are having categorical data. Okay, neighborhood, exterior 1, exterior 2. First of all, let's have a look at how many labels each variable has. So I'm gonna run for loop to see how many labels do we have. Let's print the numbers. So if you see, neighborhood has 25 labels, exterior 1 15, exterior 2 16, and sales price 663 labels. Okay, let's explore the unique categories under this. So neighborhood 25 labels, so these are the 25 unique labels. Rows are 663, total number of rows are 663, but unique values are this. I want 0 for this, 1 for this, 2 for this, 3 for this, so on and so, right? So I will have the count starting from 0 to 24 for neighborhood, or 1 to 25 for neighborhood, whereas total number of rows are 663. So this is what label encoding will help us to do. So let's see the unique categories for exterior 1 and also for exterior 2. So I have 15 labels, so these are the labels, and 16 labels for exterior, these are the labels. Okay, and again, not to forget, in encoding we should divide our data into x-train x-test, y-train y-test. Let's split the data. I don't want to consider the sales price. This is my predictor y column. Let's remove that. Test size is 30%, and show me the shape of the data. 1022 training data set, testing data set 438, and we have 3 columns each. Cool. Let's perform the ordinal encoding now. And to perform this ordinal encoding, all I need to do is assign a number to each unique type. Ordinal encoding is what? I just want to assign a number, whether it can be random or sequential. This is what you need to decide. So this needs to be 1, 2, 3, right? That's what I'm doing here by using enumerate on neighborhood column for specific one column for now. Okay, and for unique data set, start with 0. You can decide whether you want to start this count from 0 or 1. And let's see how does ordinal mapping looks like. So you see this, every unique category has assigned some number. Simple. All I need to do is map these numbers in the original dataset. Okay, let's do that. Xtrain neighborhood.map. This is the function I'm using. A map function will replace the categorical values with these values now. For that I'm using map. This is a dictionary. So map takes a dictionary, right? And same thing I can do for test. Let's execute this and let me print the head. You see this? And for neighborhood, now I have some labels, some numbers, and not the categorical values. So original dataset used to look like this. After label encoding, I see a numbers coming for each type. Beautiful. And these are not 0 and 1s. 0 and 1s, one hot encoding. This is label encoding. Okay, same thing we can do for exterior 1 and exterior 2. Same thing I can do for other 2 columns, right? And I'm writing a function, find category mapping enumerator for each type, and doing the encoding, ordinal encoding here. Okay, let's create the functions for exterior 1 and exterior 2 and print those. Nothing different. So you see, we did the same for other 2 columns as well. So this is what a label encoding stands for. Isn't it cool? Isn't it easy? Okay, after label encoding or ordinal encoding, what is next? A count, right? If you remember from this diagram, one hot encoding we have seen already. Second is ordinal label, and third, count and frequency encoding. Let's see how do we perform count or frequency encoding now. So what is count or frequency encoding? Count and frequency encoding, we replace the categories by the count. I don't want random numbers. In one hot encoding, 0 and 1s. In ordinal or label encoding, we had random numbers or the labels, but now I want the count for each type, or a frequency. Count we can easily understand how many times that observation is coming, right? So that's the count. But frequency is nothing but you want a percentage of observation in the dataset. So for example, let's say 10 rows out of 100 are of color blue. Then I want a percentage, right? Then what is the percentage of color blue? That is 0.1. That is 10%, right? Which we represent by using 0.1. This is called frequency encoding. I am printing the percentage of that specific dataset. Blue colors are 10 out of 100. So percentage or a frequency is 0.1. That's what frequency encoding is. This might also be needed when you do the encoding in categorical data. Let's perform the same. Nothing different again. I'm gonna import the pandas and train, test and split. Read the CSV houseprice.csv, read the dataset houseprice.csv. These are the columns I'm considering. Let's print the head. We did this multiple times now already, right? Now if you see, I have categorical data. I don't want to perform label encoding now, right? I want a count or frequency. Let's see the unique labels for each data type. I'm printing the labels for each type. Neighborhood 25 labels, exterior 15, exterior 2 16, cells 663. So number of unique variables we printed here. Then again, as we have seen before, split our data into test and train, 30% test size, and consider only these columns and show me the shape of train and test. 1022 rows, 3 columns, 438 rows and 3 columns for test. How do I perform count? You just need to use a function. I'm using a very simple function called count. We know that map is a function that we use. Important here is to understand a map is a simple function which takes a dictionary. So you decide what dictionary you want to create. Do you want to create a dictionary of labels or random numbers, or do you want to create a dictionary of counts? So this time, unlike label encoding, I'm creating a dictionary of count. So for neighborhood column, I'm using values.count and converting it into dictionaries. It will give me a count. So you see names, 151 names. So I got a count for each type. For each unique type, I have got the count. So blue, whatever, blue tea, I have 2. So I got the count for each type. Now I can map this to my original data set by using map function, xtrain, neighborhood, map, and the dictionary. This dictionary you can create as per your need, whether a count or a simple sequence of numbers, a label encoding, right? It's up to you. Execute this and let's print the head. Now do you see I have the count encoded here. Similarly, I can also do the frequency encoding, what I'm doing here. So in frequency encoding, all I need percentage. So what do I need to do? I need to divide the count by total number of observations. Okay, I need a percentage. That's why I'm dividing the count by total number of observations, right? So values count will give me a count, and I'm using a simple parameter here, normalize is equal to true. This will give me a frequency and not the count. Okay, so I have a dictionary ready. Do you see? So 151 type, this is the frequency, 14%, 14.77, right? 105 is 10%. I got a percentage of each type, and let's map this in the original data set. So I'm gonna use xtrain map frequency and let's print the head. Beautiful. So neighborhood is now encoded with the frequency now. Okay, this is frequency encoding, which is percentage of each type, or you can do the count encoding. This is how the count and frequency encoding can be done. Very easy to understand, right? Important is map function and the dictionary that you need to prepare. Alright, so in this video we have discussed feature engineering for machine learning, how to perform categorical encoding, and what are the different ways to categorical encoding and implement the same using pandas. We still encourage you to do some more experiments with the feature engineering to see how it can improve the performance of your machine learning model, right? So I have uploaded these demos on our GitHub repository already. You can find the link in the description and also in the pinned comment below. Alright, and that's how we come to an end of this video. If you have any questions regarding the same, let us know in the comment below. If you found this video helpful, please subscribe to my channel and hit the like button. And don't forget to share this video with your friends and the colleagues. Thanks for watching. See you again next time. Till then, take care and bye-bye.